Welcome everyone to another interesting DSA problem which is titled as Distribute Candies. So let's start by understanding what is the problem statement. So there is a person like X or Y, whatever be the name. He or she likes candies very much. But he or she is little bit concerned about health. So on consultation with the doctor has suggested whatever be the number of candies you possess, you can at most or maximum you can have n by 2 candies. And one information provided in the form of a list here is that candy type. For example, the length of the candy type list is nothing but the number of candies he or she possesses, but the labeling like 1, 1, 2, 2, 3, 3, this is nothing but a proxy of the candy type. For example, these two candies are same, but there are two candies of the category 1. Similarly, there are two candies of the category 2 and two candies of the category 3. So this information is nothing but the candy type. What that person who have like consulted doctor decided is that okay, it's fine, he or she will be having n by 2 candies maximum, but we'll try to cover or we'll try to taste as much possible the type of candies. I will try to explain this using this particular example. Here, this is the distribution of the candy type, you can see. And how many candies are there? In this case, there are 6 candies. So based on the doctor's suggestions, that's by 6 by 2 is nothing but 3. Maximum you can have 3 candies. So the way at which the candies would be having would be pick one from this category, pick one from this category, pick one from this category. If you do so, that would be 1, 2, 3. And this count is nothing but 3. We have to return this count. See, it's like that. So let's try with another example. If the candy type is given as 1, 1, 2, 3. Here you can see the number of candies is nothing but 4. As per the suggestion, you can have maximum 2 candies. But there are 3 different types of candies. So you can either have 1 or 2 or 1 or 3, 1 or 2 or 3. It doesn't matter, it doesn't bother what is the combination at which we are having. Like at most how many candies he or she can by following the advice. That's all matters. So in either cases, the answer is 2. This is what we need to return. And let's take another example. If candy type is 6666, as per the advice, you can have maximum of 2 candies. But even though you have the opportunity have 2 candies, we don't need to have 2 candies because there is no 2 categories. There is only one category, that is 6. So the choice of having would be 6. So in this case, the answer would be 1. So at this point, if you have observed, the selection is nothing but, okay, either whatever, this is nothing but length of candy type divided by 2. This is nothing but number of, this is nothing but, this one is nothing but number of unique elements or category. So in these two cases, whatever be the minimum, that would be the answer. In the first example, it was a minimum selection between 3 and 3, and the answer turns out to be 3. In the second example, it was a choice of minimum selection between 2 and 2, and the answer is 2 itself. In the second example, it was the minimum selection between unique category was 1, 2, 3. So 2 and 3. The answer turns out to be 2. In the second thing, it was selection between 2 and 1. Answer turns out to be 1. So in the problem statement, we have to count the unique categories and the length by 2 of the candy type. That's it. Whatever be the minimum between, that's our answer. So let's try to answer it. So this is the class solution define method distribute candies. So one list is given, that's nothing but candy type, which is nothing but a list of integer. We need to return another integer. So let's use the variable, one variable to store the advice of the doctor. So let's name it as to eat. This is nothing but length of candy type divided by 2, and number of unique elements, let's save it as unique. We can save it as length of, we can use the set data structure. So this will only count the unique elements. Set candy type. So our answer is nothing but the minimum among either this variable or this variable, as we have seen in the 3 examples already. So we have to return the minimum among to eat or the unique. So that's it. So what is the time and space complexity here? So as you can see, the set data structure would be iterating into store only unique data elements here. So this would be having an order of n for both time and space complexity. So the time complexity is order of n and space complexity is also order of n. And I hope you understood this problem, and thank you for listening.